Jai Hind everyone, I am Vaishali Rastogi. I am assistant professor at Department of Computer Science and Engineering at Akgec Engineering College. So today we are having a topic of page replacement algorithm. So let's start. What is page replacement algorithm? We need to first understand that why we are using page replacement algorithm, what is the concept behind the page replacement. So
Department of Computer Science and Engineering at Akgec Engineering College. So today we are having a topic of page replacement algorithm.
Sir,
Start. What is page?
page replacement algorithm. So what is page replacement algorithm? The page replacement algorithm decides which memory page is to be replaced. Okay, first understand what we are doing here with the pages. Let's take example that we are having a program of n number of lines, and we just want to execute this complete program inside the memory, but we cannot use this much of n number of length program in a one time. So we have to divide this program in some pages. So I am dividing this particular program inside 2 or so on pages, and I have to execute this complete program inside the main memory. So what I will do, I will just divide the complete program inside the pages, and I have some limited memory, which is my main memory or RAM memory. We are having RAM and ROM. So in main memory we have to execute all the programs one by one with among the pages. So we will not put entire program inside the main memory in a one time. We will use some kind of pages, division of program inside the pages, and we will take pages one by one. We will execute all the pages one by one, and we will put all the pages inside the main memory, and it will get executed. But here the second term comes, what is replacement? Why this term is coming inside this algorithm? What kind of algorithm using this replacement approach, and why we are using it? So replacement is requiring because we are having a limited space of main memory, and we are having n number of programs, n number of pages to be executed. So if I put, let's suppose I am having a space of 10 pages in a one time I can keep inside the main memory, but what if I am having 100 pages to be executed in a single time? So in this case page replacement comes in the scenario. What is the replacement working here? That up to 10 I will execute all the pages inside the main memory, but when the 11th page will come in the scenario and I am having only 10 pages placed, so I will replace one page which is currently executing inside the main memory. I will replace that page and put another page to be executed. So do you understand that? Yes, Dilip. So do you understand that what I am saying to you? I am just saying that we are having a limited space of main memory and having n number of pages which is larger than the capacity of main memory, and I am just putting all the pages to be executed inside the main memory. But when the main memory is full, now I just want to put another page inside the main memory. That the scenario I will use the replacement terminology. I will just replace one page and put another page inside the main memory, and the executed page will go back to the another secondary memory. So this definition is saying that the process of replacement is sometimes called swap out or write to disk. Means I am having another secondary storage or disk for placing these pages when they are not currently in execution. Means whenever the CPU is executing any kind of pages, the pages is remaining inside the main memory, but the main memory is full right now. So I have to replace the page, I have to put another page inside the main memory, and I have to replace that page to secondary disk storage. So this exchange or replacement is called basically swap out or write to the disk. We can also call it swap in whenever we are just taking any page from disk and putting inside the main memory. Okay. So this is the process of replacement. Now page replacement is done when the request page is not found in the main memory page fault. So let's take a very good example. I am having a storage of 5 pages. This is my main memory and it is the capacity of holding 5 pages in a one time. And it is holding 5 pages A, B, C, D and E. And my F pages wants to execute inside the main memory. So I have to replace one page. I will just, for example, I will removing A or B, whatever you want you can remove. I am removing A and putting F inside the main memory. So whenever I am requesting any page like F which was not already present inside the main memory, this situation called page fault. Okay, if my next page is requirement of C, C is also inside the main memory right now. So this situation I will say as page hit. Whenever I am requesting any page which is already residing inside the main memory, this situation called page hit. Whenever I am having any kind of page to be executed which is not already inside the main memory and I have to call it from the another secondary memory and it is coming from secondary memory to main memory, this situation is called page fault because page is not found inside the main memory. This is the requested page is not found inside the main memory. This situation is called page fault. I hope it is clear to you. If you have any doubt, you can write in the chat box regarding page fault, page replacement. If you have any query, please write it over here. Okay, so if I miss any kind of your chat box message, I will reply it later. Let's continue with the next slide. Types of page replacement algorithm. We are having 3 types of page replacement algorithm. First one is FIFO, another one is optimal page replacement algorithm and third one is LRU. I am starting with the FIFO. What is FIFO? The full form FIFO is first in, first out. Means I am having some pages like A, B, F, X, O, N. This is the sequence of pages. So in FIFO says that whatever the page is coming first, it will get executed first and the replacement is also depending upon the frames sequence. Means frame 1, 2, 3 and 4. If I have already first time the main memory is full, and I have to replace any page, I will start it from frame 1, then frame 2, then frame 3 and then frame 4. This is my concept of FIFO. In this algorithm, a queue is maintained, the page which is assigned the frame first will be replaced first. Okay. In other words, the page which resides at the rear end of the queue will be replaced on every page fault. So let's take an example of first FIFO. Before that, I am just describing in words optimal page replacement algorithm. This algorithm replaces the page which will not referred from so long in future. Although it cannot be practically implementable, but it can be used as a benchmark. Other algorithms are compared to this terms of optimality. Means in this kind of algorithm, optimal page replacement, we are having like A, X, N, O, P, Q, S, T, this kind of pages. Okay, and right now my CPU is executing with the N or P. So I will next request is having Q. So I have to replace one page inside the frame. I will replace that page which will not come frequently in future. Means let's suppose right now I am having A, X, N, O and I have request of P and I have to replace one page from inside the main memory. In such situation, I will replace one page. Which page I will replace? Will see A, X, N, O and I am having either X, N, A, O. N. I will see in among A, X and O which page is coming at last. I will replace that page. So A, X, N, O. You can see here N is coming at last inside this page sequence. I will replace N over here and I will put P inside this frame. So this is the concept of optimal page replacement algorithm. So let's continue with another page replacement algorithm, which is least recent used. We also call it LRU in short. LRU page replacement algorithm replaces the page which has not been referred as a long time. This algorithm is just opposite to the optimal page replacement algorithm. In this, we took at the past instead of starting at the future. Means here we will just apply the opposite scenario of optimal page replacement. Here in this LRU, I will use the same methodology of selecting the page replacement frame. I will just select among A, X and O, which is used in the previous scenario. Means currently I am having P and A, X and O. Which one has come first? A. So I will replace A among A, X and O and put P over here. Again I am having request of Q, and in the frame I am having P, X and O. So among P, X and O, P, X and O, X is used first in my past. So I will replace X over here and put Q inside the main memory, and it will get executed accordingly. So this is the concept of my LRU, means the opposite of optimal page replacement algorithm. This algorithm replaces the page which has not been referred for a long time. So I have tell you all these three algorithms theoretically. So I will just take example of each algorithm and I will solve over here. If you have any query, you can write in chat box. So first example I am having of FIFO, first in first out. So here the question is, consider a main memory with 5 page frames and the following sequence of page references 382, 391, 638, 936, 213. Solve using page replacement policy first in first out. Okay, so let's start. I have seen this, there are some conditions. First condition is that I am using the FIFO terminology. FIFO algorithm I am going to use to solve this question, and another condition is that number of frames are 5. I have already told you that memory is having some division of frames. So in this question I am having a space of pages 5 frames on a one main memory. It means that 5 pages can reside in a main memory at a one time. Another 6 page will come, then I will apply the page replacement algorithm. So let's start. One more thing I want to tell you, that I have told you the concept of page hit and page fault. We have to calculate the page fault as well the page hits. So page fault we will calculate as whenever we are not finding the pages inside the frame. That situation we will calculate as a page fault. Whenever any page we are requesting which is already present inside the main memory, this situation we can call as a page hit. So let's start with the example. So condition is number of frames are 5. Let's start. So here you can see I have already used a matrix kind of diagram. You can write any kind of frame size like this, 1, 2, 3, 4, 5, so on. You can use also this kind of methodology to solve this approach, but due to lack of space I am just using the pre-structured matrix of 5 frames. This frame I can call it as frame 1, frame 2, frame 3, frame 4, frame 5. Okay, so these are the 5 frames. Let's start with the question. So first element or first page we are having as 3. Currently the main memory is empty. So just you can understand, whenever the page is not available inside the main memory, this condition we called as a page fault. So 3 is not present inside the main memory. So we will write 3 as a page fault. So I will mark as a page, we can call it as a page miss or page fault, both are the similar things. So I am just marking as a M, page miss. Okay, so page miss I am just denoting with the M, and page hit I will denote as a H. So next I am having 8, 3 is already present inside the first frame. Next I am having 8, I will put 8 over here because frames are empty, but again 8 was not present already inside the main memory. In such scenario I will write it as a page miss or page fault. Okay, now I am having 2, 3 is already present, 8 is already present, 2 is not present inside the main memory. In such scenario again we are having a page fault or page miss situation. Okay, so next 3, here you can see that we are having the request of page 3. Page 3 is already present inside the main memory here. So this scenario, this condition, we can call it as a page hit. So I am just representing it as a H because 3 is already present inside the main memory. So 3 is the same, 8 and 2. Now I am having the request of 9. So 9 is not present inside the main memory. So it is a page miss again because 9 was not present inside the main memory. Now I am having 1. 1 is not present inside the main memory. Again it is a page miss. 3, 8, 2, 9 and 1. Now all frames are full. Here the scenario will start with the first in first out because frames are full. If any page will come over here, then I have to replace one frame and put that executable page inside the main memory. So I am having the request of 6 here. Frames are full. Now I have to apply the approach of FIFO. So FIFO says that we will replace pages in a sequence. Means we will replace the page which is the first entry. First entry we have started with the frame 1. So we will replace 3 over here and write 6, and 6 was not present inside the main memory. So it is a page miss. Okay, and all frames will be remain same situation. So we have put 6 over here. Now I am having 3. Yes, Piyush? Ma'am, having higher number of frames is better or having lower number of frames? It depends on the size of the main memory. If we are having larger size of main memory, so we can use maximum pages inside the main memory. It completely depending on the space of main memory. Very good question, Piyush Singh. Okay, so I think it is clear to you that if we are having higher memory space to execute smaller tasks, this is a good situation. If we are having a large number of pages over here and we are having smaller size of memory, this is the some complicated kind of situation. Okay, so we were at 3, we were going to put 3. So 3 was not present inside the main memory, it is again a miss. But now this algorithm says replacement is required over here. Where we will put 3? We will see that F1 is already replaced. Now the second priority of comes with the F2. So we will replace 8 over here and we will put 3. Ishika, if you have any query, you can ask. Okay, so now it was a page miss again and we have placed 3 over here. Now we are going to put 8. 8 was not present inside the main memory, so it is a page miss. Where we will put 8? We are just moving with the FIFO, first in first out. So we have seen that F1, F2 is already blocked, already replaced. So now we have the scenario of F3 frames because we are just moving in the sequence. So we will just shift 2 from the main memory and put 8 over here. All other frames would be remain same. Okay, so 8 has been placed. Now we are having 9. 9 is already present inside the main memory. Okay, so 9 we are having inside the main memory. 9 is a request. This situation called as a page hit. Okay, so I will place I have to no replacement is required over here. This is the situation of page hit with 9. Okay. So now we are having 3. 3 is already present inside the main memory. It is again page hit. So 3 is already present inside the main memory. It is a hit. Now we are having 6. 6 is already present inside the main memory. It is a again hit, because we are not requiring to replace this page because this is already present. Now we are requiring for 2. 2 is not present inside the main memory. In such scenario, we have to apply the replacement algorithm. We have already replaced up to the frame 3. Now we will replace the frame 4. Frame 4 is having 9 right now, and I will write 2 over here. All will be the same. And it is a page fault because we have replaced some pages. We were looking for 2 and 2 was not present inside the main memory. Again, it is a page miss. So now we are having 1. 1 is already present inside the main memory. It is a hit. Okay. So now we are having 3 inside the main memory. Yes, it is again hit. So it is a again hit. Now after calculating all this process, we have to calculate number of hits and number of miss or page fault. We were already saying that how much page faults we occur in this question. So let's count. Total number of references, first we will count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So page references are 15. Total page references are 15, and page hits 1, 2, 3, 4, 5, 6. Page hits are 6, and page miss 1, 2, 3, 4, 5, 6, 7, 8, 9. So page fault, you can say it a page fault or page miss. We are having 9. 9 page faults. Here you have to also calculate the hit ratio and miss ratio. So I am just writing the formula over here to calculate the hit ratio and miss ratio. It is a very easy process, and I want you to the students to calculate this because it's a very smaller thing. So I am just writing the formula to calculate the page hit ratio and page miss ratio. You just calculate and write into the chat box. So here I am just writing the formula for page hit ratio is equal to number of hits divided by total number of references multiply by whole multiply by 100. Okay, there is no space. So you can see over here, number of hits divided by total number of references multiply by 100. This is the formula of hit ratio. Okay, and again if we need to find out the miss ratio, so number of page fault or number of miss total divided by total number of references multiply by 100. So this is the basic formula for calculating the hit ratio and miss ratio. Okay, let's continue with the another algorithm, which was optimal page replacement. So optimal page replacement says that we are having some string of pages and we have to replace the pages depending on the future coming sequence. Means we will replace the frames where, means right now A, B, C, D. Whenever E will come, we will see among A, B, C, D which page will come in last in future. Okay. So if in this scenario C is coming in last, then we will replace C, or in this scenario again among all these frames B is coming in last in future, then we will replace B over here. This is the only change in this algorithm. So again we are having the question of 7, 0, 1, 2, 0, 3, 0, 4, 3, 0, 3, 2, and we are having the condition of frame size 4. And we have to solve this question using optimal page replacement algorithm. Okay, Shantanu, Tarun, if you have any query, you can ask over here. and I just want you to take pen and paper and solve this question with me, so that you can also give answers in chat box. Okay, let's start. First we are having frame size 4, F1, F2, F3, F4. 4 frames are here. Okay, and we are having a string of page sequence 7, 0, 1, 2 and so on. Let's start. So first we are having 7. Right now my main memory is completely empty. No page is residing inside the main memory. This situation we will say as a page fault or page miss. I will put 7 over here. Again, next number I am having, next page number I am having as a 0. 0 is not present inside the main memory. I will write as a 7 and 0, which is my again miss. Okay, next is 1. 1 is not present inside the main memory. I will write 1 over here because frame is free. 0 and 7, and it is also a page miss. Now we are having 2. We are having one space for 2. I will write 2 over here. It is a page miss because 2 were not present inside the main memory. So it is a page miss. Now all my 4 frames are full. Now we are having 0. But 0 is already present inside the main memory. In this situation, we call it as a page hit. Okay. Now I am having 3. But 3, you can see 3 is not present inside the main memory. At this scenario, we have to use the optimal page replacement. So optimal page replacement we will apply with 7, 0, 1, 2. Here we will use, now right now we are having at 3. Here we will use the methodology to see for future. We will see among 7, 0, 1, 2 which page is coming at last. Okay, so let's start. 0 is here. Okay, 4 is not requiring. 2 is here. Okay, now 3 is here. Okay, no, 3 was not here, and 3 and 2. Here we are having 1 and 7. 2 numbers, 2 pages which are not inside the string also. So we can use it as a frame for replacing. Yes, Riya. Okay, so here I have choice to replace 7 or 1. I can replace 7. This is my approach. I can also replace 1. So just because of the coming scenario, I am just for my choice. You can also replace 1. I am just removing 7 and writing 3 over here. Okay, and it is a page miss. All the frames are the same values. Okay, so I have placed 3 over here. Now I am having the choice of 0. 0 is already present inside the main memory. So 0 is a page hit. 0 is done. Among, right now I am having request of 4. 4 is not present inside the main memory. Here I have to apply the page replacement algorithm. So optimal approach says that look for the future one. 3, 0, 1, 2. So from 4, this string is there. 2, 3, 0, 3, 2. 2, 3, 0, 2, 3, 0, and 1 is not used in future. So we will replace 1 over here, and I will just put 4 inside the main memory, and it is a page miss. Okay, so again I have 2 is already present inside the main memory, so I will write 2 over here, and it is a page hit. Now I am having 3 sorry, 3 is already present inside the main memory, so again it is a page hit. Now I am having 0 is already present inside the main memory, it is again hit. Now I am having 3 is already present inside the main memory, so I will use as a hit. Now I am having 2 2 is already present inside the main memory, so I will just write it as a hit. Okay, so my question is over, string is over now. Okay, in this approach we have seen that we were just replacing the number which were coming at last, okay, at last in future. So we were looking for the future string. That's why this algorithm says it as a optimal page replacement, because you can see that number of hits are larger than FIFO. FIFO what? First in, first out. Yes, Piyush, out of 7 and 1 we could have replaced either of them or one which came first. Piyush, you are discussing about this situation 7012. In this situation we were just need to replace 3. This was the situation. Okay, so we have to decide, we have to replace 7, 0, 1 or 2. In this scenario we have seen after 3 in future, among 7, 0, 1, 2, which page is coming at last. So I have seen 2 is coming over here, 0 is also coming, 3 is also coming. If my 7 is here, let's suppose if my 7 is there, also in this situation I will replace 7. But right now 7 was not present inside the string, and 1 is also not present inside the string. In this scenario I have the choice of replacing 7 or 1. Yes, Riya, very good, Riya, you are just, I think you are watching it properly, that's why you are able to give answer, very nice. So let's calculate number of references. Total number of references are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so total number of references are 13, 3, 4, 5, 3, 4, 5, 6, 7, 8, 9, yes, 13 is total number of references, and number of hits are 1, 2, 3, 4, 5, 6, 7. Number of hits are 7, and number of miss 1, 2, 3, 4, 6. Okay, number of miss are or page faults are 6. So number of page faults are 6. You have to calculate the hit ratio and miss ratio. I have already told you about the formula, you can write it again. For finding the hit ratio, the formula is number of hits divided by total number of references, number of hits divided by total number of references multiply by 100. This is the formula of finding hit ratio. Okay, so now I am going to calculate the page replacement, total number of page replacement. I have calculated 6. I am going to find out the miss ratio. So how we will calculate the miss ratio? Total miss ratio means 6 divided by total number of references multiply by 100. This would be my final miss ratio. Yes, Bhavya, very nice. Bhavya, do you have any query, beta? Okay, let's calculate another one. Least recent used LRU page replacement algorithm. In this algorithm we are just using the approach opposite to the optimal. In optimal we were looking for the future, in LRU we will just go look for the past string. We will replace that page which already used and least recent placed in past. Okay, so here in this scenario, if I am having A, B, C and D, and E is requiring page, E page is requiring place inside the main memory, but my main memory is full right now. Here I have to apply the LRU page replacement. So I will replace that page which I have used in least recently. Okay, so among, I will see that if I have used C, B or A or D, among all these pages, the first element or least element I have used in past, I will replace that page and I will put my new page over here. Okay, so let's calculate. Sorry, least recent used page replacement algorithm, we are using this approach and we are having a reference string of this. The situation is that number of frames are 3. So Piyush, you were telling the number of frames are lesser, then what would be the situation and what is the effect of larger number of frames? You can see in this scenario, here we are having less number of frames, and in our first question we were having the higher number of frames as 5 comparative to 3. So here we are having frame 1, frame 2 and frame 3. 3 frames we are having over here, and we are having a smaller string. Let's calculate this question. And so first we were having all the approaches of finding hit, finding mid are the same. Okay, so 4 is here, 4 is not present inside the main memory, so it is a page miss. I will write 4 over here. Again 7 is not currently present inside the main memory, it is a page miss. Again we are having 6. So 4, 7 and 6 frame is empty and it is again a miss. We can see that one scenario with lesser number of frame, that replacement is faster and comparatively larger than other algorithm. If we are having less number of frames, then we have to apply the replacement algorithm frequently, because we have limited capacity. So this is the live demonstration of using lesser number of frames and higher number of frames. In higher number of frames we are having capacity comparatively more, because we can place more pages inside the frame, and the situation of replacement comparatively is lesser among inside the larger number of frames. So here after 3 pages residing inside the main memory, we are having the situation of replacement. So here we are using least recent used page replacement. So what's it is requiring for 1 we have to put, and we are having 4, 7 and 6, which we will remove, because least is saying we will look for past. Here I want your response too. I just want to know you that you are able to understand this concept or not. Okay students, just write. In least recent used, in optimal I was looking for the future, in least I am looking for the past. So what kind of approach I will apply over here? I have to place 1 inside the main memory. So among 4, 7 and 6, which element, which page I will remove first? Yes Ria, you have given the answer. Okay. This kind of questions is very important in your university examination, and it should be on your fingertips, because it is a very similar but little bit difference among all these algorithm, and it is also having a very good chances of priority inside of coming inside the university exam paper. Okay, so 1 I will replace 4 over here, as Ria has given the answer. Yes Tarun, Shantanu, yes 4, very nice. So I will put 1. Why? I am also explaining you, because among 4, 7 and 6 in past I have seen that 4 was recently used. Okay, least recent used among 4, 7 and 6. So I will write 1 and it is a page miss. Again now I am having 7. 7 is already inside the main memory, it is a page hit. Now I am having 6 also inside the main memory right now, so no need of replacement, it is a page hit. Now again 1 is already present inside the main memory, it is a 1, it is page hit. Now I have 2, I have to place 2 inside the main memory, and this is the future past string for 2. Just tell me which page I will replace among 1, 7 and 6. Yes, Tarun. Among 1, 7 and 6, I have to place 2. Among, this is my sparse string. Ayushi, single. Okay. Anyone else? Anyone? Kavyanshi, yes. Jai Hind. Anyone wants to explain why I have to replace 7? Why you are saying that among 1, 7 and 6, 7 is going to replace by 2? Can you write the reason? Kavyanshi? Shantanu? Okay. So here, as you given the answer, 7 will be replaced by 2. It is 6 and 1. And what is, because 2 was not present? Yes, Riya, you have given the answer. Because if we move from right to left, 7 comes at the end. This means it is least recently used. Very nice, Riya. Yes, Ayushi. Very good. Very nice. So, again tell me, it is a page fault, page miss or page hit? Just tell me, it is a page hit or page miss? 2 was not present inside the main memory. Riya? Yes, Shantanu, yes. It is a page miss because it was not present inside the main memory, right answer. So now we are having request of again 7. In this scenario, we will see among 1, 2 and 6 which will be replaced, because I have to place 7. Tell me, among 1, 2 and 6, which I will replace first for putting 7 inside the main memory? I think this video is getting some seconds of delay. Yes, Riya, Tarun, you are saying 6. Why? Because we are going to put 7, and among 1, 2 and 6 in my recently used page replacement algorithm, among 6, 1 and 2, see 6 at the least position. That's why I will remove 6 and put 7 over here. So this is my page miss again, because 7 was not present inside the main memory. Now I am having 2. 2 is already present inside the main memory, hence it is a page hit. Yes, Rhythm, right answer. So calculate number of total references. Total references are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total references are 10. Okay. And number of hits are 1, 2, 3, 4. And number of miss, you can see over here, it's 6. Just calculate the hit ratio. I want the answer for hit ratio. Okay. The formula of hit ratio is number of hits divided by number of references multiply by 100. You can see on the screen that number of hits are 4, number of miss are 7, and total references are 10. So calculate the hit ratio for this and write in the chat box. Jai Hind Shadab. Okay. So calculate the hit ratio for this. Hit ratio for this question. Simple, it is very simple. 4 divided by 10 multiplied by 100. You can calculate by it. Okay, and I just want your answer in chat box because it is a very simple calculation. Yes, Tarun. Okay, and number of miss. Number of miss is a very smallest question I am asking to you. 6 divided by 10 multiplied by 100. It's a very easiest and very smallest question. Okay, so it is all about my least recent used page replacement algorithm. We have seen, again I am just giving you a quick review of, first we have understood what is FIFO. FIFO is my first in first out. You should understand these differences on your fingertips. FIFO says that which frame will use first, it will be removed first. Okay, this is the basic concept. And in optimal we will see the future string and we will see the which currently frame among which frame which will come at last in future. Okay, and the opposite concept of optimal page replacement we are using as a LRU. Here we will see the past string and the number or pages which is least recently used in our past string. So it was all about all these three algorithm. I hope you have understood all the concept of these page replacement algorithm. So it is all about today's lecture. So thank you so much for joining this session. If you have any query, you can write in chat box. Okay, thank you so much.